So this question is based on the probability distribution of a random variable, probability distribution of a random variable. So here it is asked to find the probability distribution of the number of heads in two tosses of a coin. So here the random variable x, that is the number of heads, the number of heads, and the sample space of this experiment is, so the name of the experiment is two tosses of a coin. So the sample space would be both heads, or I can get head, tail, or I can get tail, head, or I can get both tails. So there are four outcomes. So therefore, uh, so the probability of x equal to 0, it means we should get both tails in the two tosses. So it will be probability of getting tail times the probability of getting tail. So that would be 1 by 4. And then the probability of x equal to 1, it means we should get one head. So that would be one head. So that would be 2 into, so we will get one head and one tail. So that would be 1 by 2. And similarly, the probability of x equal to 2, it means we should get both heads. That would be 1 by 2 into 1 by 2. That is also 1 by 4. So therefore, here in this case, for the part 1, the required probability distribution will be, the required probability distribution is given as, for x equal to 0, 1, and 2, the probability of x, that would be 1 by 4, 1 by 2, and 1 by 4. So this is the required probability distribution for the first case. And for the second case, it has been asked that here the random variable is defined as the number of tails, the number of tails in the simultaneous tosses of three coins, in tosses of three coins. So if three coins are tossed, then the sample space would be head, 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 and head, head, tail, then head, tail, head, and that would be tail, head, head, and it can be tail, tail, head, and tail, head, tail, head, tail, tail, and all three tails. So there are 8 possible outcomes. So therefore, we need to find the p of x equal to 0. It means we should not get any tail. So it means all three are heads. So that would be 1 by 8. No, sorry. Yeah. So in the first toss, we should get head times, for in the second toss also head, and the third toss also head. So this would be equal to 1 by 8. And in the same way, p of x equal to 1 means we should get one tail. So that would be, one tail means 3 into, we can get one head and one head and one tail. So this would be 3 by 8. And p of x equal to 2 means we should get two tails. It means it will be 3 into 1 by 2 into 1 by 2 into 1 by 2. So this would be, so here we are getting two tails here and one head. So this would be also 3 by 8. In the same way, p of x equal to 3, it means we should get all three as tails. So this would be 1 by, should be 1 by 2 into 1 by 2 into 1 by 2. So this would be 1 by 8. So therefore, here in this case, the required probability distribution will be is given as, so x will be 0, 1, 2, and 3, and the probability of x, that would be 1 by 8 and 3 by 8. This would be 3 by 8, and this would be 1 by 8. So this is the required probability distribution for the second case. And for the third case, it has been asked to find the probability distribution of the number of heads in 4 tosses of a coin. So here the random variable is defined as the number of heads. The number of heads in the 4 tosses of a coin. Number of heads in the 4 tosses of a coin. So when 4 coins are tossed, 4 coins are tossed in the sample space would be all 4. I can get heads, and we can get head, 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 tail, and head, head, tail, head, then etc. till all 4 can be tails. So here we would get like 2 into 2 into 2 into 2. So we will get 16 outcomes. 16 outcomes in the sample space we'll get. Means 16 are the total possible outcomes in this case. So here P of x equal to 0. It means when there are no heads in the 4 tosses of a coin. So no heads means all 4 should be tails. All 4 are tails. So this would be 1 by 2 into 1 by 2 into 1 by 2 into 1 by 2. So that would be 1 by 16. And similarly, P of x equal to 1. It means I should get 1 head. What is the probability of getting 1 head? So that would be so in the 4 tosses, any one can be head. So I will do 4c1 times 1 by 2 whole power 4. So that would be 4 into 1 by 16. So that would be 4 by 16. That is 1 by 4. Okay, so then P of x equal to 2. It means the probability of getting 2 heads. So 4c2. So out of these 4 tosses, we can get any 2 as heads. So times 1 by 2 into 1 by 2 into 1 by 2 into 1 by 2. So that would be 4c2 means 4 by 2 into 3 by 1 into 1 by 16. So that would be 2 to the 4, 2 8 is the 16. So that would be 3 by 8. And similarly, the probability of x equal to 3 means we should get 3 heads. So out of these 4 throws, I can get any 3 as heads by 4c3 ways into that will be 1 by 2 whole power 4. So that would be 4c3 is 4 only times 1 by 16. So that would be also 1 by 4. And the probability of x equal to 4 means um, all 4 are heads. So that would be 1 by 2 into 1 by 2 into 1 by 2 into 1 by 2. So that would be also 1 by 16. Therefore, the required probability distribution is the required probability distribution of this given random variable x is, for x, the values of x can be 0, 1, 2, 3, and 4. And the probability of x, P of x, that would be 1 by 16, and this would be 1 by 4, this would be 3 by 8, this would be 1 by 4, and this would be 1 by 16. So this is the required probability distribution in the third case. So this is your final answer. Thank you.